Welcome to this explainer, brought to you by FountainBridge Initiatives. Today, we're diving into a massive, honestly mind-blowing collaborative breakthrough in global health. You know, we usually picture cutting-edge medical science happening in these brightly lit billion-dollar laboratories, right? But what happens when the absolute front line of a disease is literally thousands of miles away from the nearest power grid? Well, today, we're looking at a completely ingenious solution that flips the script on medical diagnostics, bringing world-class testing straight to the most remote villages on Earth.
Okay, let's get right into it and talk about this hidden enemy, urogenital schistosomiasis. It's a bit of a mouthful, so you might also hear it called bilharzia. Basically, this is a devastating parasitic infection caused by microscopic worms, and it's often referred to as a disease of the poor, simply because it thrives in rural, resource-limited communities. The parasite actually spreads through contact with freshwater that's been contaminated by a very specific snail host. And over time, the human immune system reacts to the parasite's eggs that get trapped in the body's tissues. The result of all this? Severe damage to the urinary tract, a drastically increased risk of bladder cancer, and even a high risk of infertility. In some regions, it can actually increase the transmission of HIV. It literally traps millions of people in this really heartbreaking cycle of poverty and poor health. To really grasp the scale of this issue, we need to ground ourselves in the actual communities where this happens. Take a look at this. This is Imrala Odo. It's a beautiful yet very remote rural community right along the Oyon River Dam in Ogun State, Nigeria. In places exactly like this, interacting with local waterways isn't some optional weekend activity, it's literally a matter of survival. Everyday, essential activities. We're talking fishing, farming, washing clothes, just bathing. These expose residents constantly to that snail intermediate host we just talked about. I mean, you can't exactly tell people to just avoid the water when the water is their entire livelihood, right? Now, here's the really frustrating part. Treating this disease is absolutely possible with medications like praziquantel. But the tragedy is you can't treat what you can't diagnose. And standard testing for this disease relies heavily on centralized laboratory equipment. We are talking about expensive, super delicate microscopes, centrifuges, a steady, reliable supply of electricity, and highly trained microscopists. And let's be real, these rural communities simply do not have access to that kind of infrastructure. The distance and the cost are just insurmountable barriers. This right here is what we call the diagnostic bottleneck. So how do you solve a bottleneck that massive? Well, you need a massive, highly coordinated effort. And that is exactly what happened when a staggering 17-institution global alliance formed to tackle this head-on. The roster is incredible. Spanning the US, you have McGovern Medical School at UT Health Houston, Stanford, Cornell, UT MD Anderson Cancer Center, Marian University, the University of Texas Medical Branch, Baylor College of Medicine, and Health in Your Hands Diagnostics. They joined forces with amazing Nigerian partners, including the Federal Medical Center Abeokuta, the Federal University of Agriculture Abeokuta, the University of Ibadan, and the Ogun State Ministry of Health. Plus, international partners jumped in, like Jana Medical and Dental College and Ashoka University. And absolutely crucial to this was the on-the-ground leadership from FountainBridge Humanitarian and Leadership Initiatives. This whole operation was spearheaded by brilliant researchers, folks like William C. McCarthy, Caroline J. Crane, Tope Ulubudun, Ifelua A., George, and Manu Prakash. And they worked right alongside incredible local leaders, especially Adelewe Ihesan and Boluwatefe Di Oladokun from FountainBridge. The solution this dream team came up with is just pure genius. They call it frugal science. Instead of trying to somehow drag an entire modern lab out to a remote village, they completely reinvented the lab. They engineered this totally electricity-free kit combining two main pieces. First, an origami-based paper microscope called a foldscope, which was originally developed in Manu Prakash's lab at Stanford. And second, a custom-designed, reusable stainless steel mesh card called the Schistofilter. The Schistofilter is brilliantly designed to perfectly trap those tiny parasite eggs, which lets you view them directly through the foldscope. Now, this innovation doesn't just make the test portable, it completely shatters the financial barrier. The entire toolkit costs less than $4 to assemble. But here's the real kicker. Because the foldoscope doesn't need any special consumables, and that Schistofilter can be washed and reused hundreds of times, the actual cost per test plummets down to just 2 to 4 cents. Let that sink in for a second. For literally pennies, we can completely wipe out the financial barrier to disease detection in these hard-to-reach communities. It's a real game changer. And what's really cool is how this ingenious toolkit translates into a super simple 4-step workflow that totally bypasses the need for a traditional lab. First, you just collect a standard 10 milliliter urine sample. Step 2, that sample gets pushed through the schisto filter using a basic syringe. Step 3 is where the magic happens. The filter goes right into the foldscope. The examiner then magnetically snaps a regular old smartphone onto the foldscope lens, and boom, they can view and document any trapped eggs right there on their phone screen. Finally, step 4, the filter is just washed in sterile water, and it's instantly ready for the very next patient. But, having a cheap tool really isn't enough if you don't have someone there to actually use it. And that brings us to the true hero's twist in this story: diagnostic task shifting. The Alliance realized they had to shift the diagnostic power away from distant, often overworked lab technicians. Instead, they put this toolkit directly into the hands of community health extension workers, or CHOOs for short. These are local folks, they are highly trusted and already deeply embedded in these rural communities. Now, they aren't trained microscopists, not at all, but armed with this simple toolkit, they essentially became the frontline diagnostic defense for their very own neighbors. Naturally, you're probably wondering, can non-experts really diagnose a microscopic parasite accurately? Well, the data gives us a resounding yes. The learning curve we saw across their sequential village visits was honestly staggering. At their very first village, Imala Odo, their accuracy hovered around 52.5%. Basically a coin toss, right? But they were just learning the system. By the third village, Apojola, they jumped to nearly 71%. And then, by their fifth village visit in Abale Sikaru, these local community workers skyrocketed to an astonishing 92.1% diagnostic accuracy when compared to gold standard laboratory tests. So that 92.1% accuracy rate is absolutely crucial. Sure, under perfect lab conditions, the foldscope itself, it's over 99% specificity. But hitting 92.1% accuracy out in the field, done by community health workers who had literally never touched a microscope before this study, that is a monumental triumph. It definitively proves that decentralized, community-led diagnoses using these ultra-low-cost tools isn't just some nice academic theory. It's highly effective, it's incredibly scalable, and it is ready for the real world right now. And while the numbers are great, they really only tell one side of the story. Hearing the confidence of the local health workers brings this incredible human warmth to the data. During some of the qualitative interviews, one of the CHUs actually said, if you see any tools at all, we can make use of them. If we are trained on how to use it, we will use it. They felt so empowered. And because they're already trusted by their neighbors, patients felt completely comfortable providing samples and getting their diagnoses. The tools are just the vehicle here. The deep trust these workers have within their community is the real engine driving this whole intervention. As we step back and look at the incredible success of the 17-institution partnership in Ogun State, we're left with a really powerful realization. Frugal science works. Community empowerment works. So what you should take away from this explainer today is a genuine sense of immense possibility, which leaves us with one final thought to ponder. What if the key to eliminating the world's most stubborn, debilitating diseases isn't some billion-dollar machine, but a $2 piece of paper placed firmly in the hands of a trusted neighbor? Thank you so much for exploring this fascinating topic with me.